Good morning, students. Today we are going to solve a question from the Chemistry A levels, paper number 3. And the topic is transition elements. A part is explain why so many transition element complexes are colored. So the reason is required why many of the transition element complexes are colored. So here are the reason. Attend to yourself. In transition element complexes, the central metal ion has partially filled d subshell. So this is the reason why most of the transition element complexes are colored, because the central metal ions has partially filled the d subshell. This allows DD transition. When an electron in the lower d subshell is excited, it absorbs wavelengths in the visible spectrum. So hence color complementary to these wavelengths absorbed is observed. So this is due to the partially filled d subshell, and whenever the electron in the lower d subshell is excited, it absorbs the wavelength in the visible spectrum, due to which it seems to be colored. Okay, B part of the question is anhydrous copper sulfate is a white powder which readily dissolves in water. Describe and explain what is seen when copper sulfate is stirred with water, followed by the addition of the ammonia aqueous form until in excess. So copper sulfate first will be stirred with the water, and then ammonia will be added in it. Okay, concentrate yourself now. The white powder first turns into blue crystals whenever it is actually reacted with the water. So this will be the white powder of the blue crystal will be formed. Okay, so copper sulfate plus water forms the blue crystals. Okay, it then dissolves in water to give a blue solution, and this blue solution is due to the presence of this copper ion. So this blue crystals, when further added in the water, further dissolved in the water, this copper ion, sulfate ion, and the water molecule will be formed. Further, when aqueous ammonia is added, blue precipitate of the copper hydroxide will be formed, which then dissolves in the excess NH3 to give a deep blue solution containing the tetraamine copper ion. So this thing is responsible for the deep blue color. So look now, the copper ion which was formed here, now it will further reacted to form the copper hydroxide. This copper hydroxide will be dissolved in ammonia to give the tetraamine copper ion, which is responsible for deep blue coloring. Next part is C part. Blueprints. The detailed plans for the architectural or engineering projects were made in 19th century by forming the insoluble complex, that is Prussian blue or sensitized paper. Prussian blue is the name given to the deep blue precipitate formed by adding solution of the iron ion to a solution of the hexacyanoferrate ion. A part's first part requirement is construct a balanced equation for the reaction when iron ion will be reacted with the hexacyanoferrate ion. So the balanced equation is here. This is iron ion, this is hexacyanoferrate ion. So when four of the three ions will be reacted with three of the hexacyanoferrate ions, this will form hexacyanoferrate molecule, which will be in solid form. Okay, second part of the C part is suggest a reason for the difference between the redox potentials. So look now, here are two different reactions, and redox potentials are different. So this is the requirement why there is a difference in the redox potential. So concentrate now. This is more tough and technical question. Okay, when cyanide ion is a strong ligand and it stabilizes iron 3 with respect to iron 2. So this is the reason cyanide ion is strong ligand and it stabilizes iron 3 more with respect to iron 2. Okay, hence it makes hexacyanophorate ion more difficult to reduce to the iron 2 state compared to the hexa aquaferrate ion. Therefore, the potential difference is there in the hexacyanophorate ion is lower. The last part is suggest why the red color of the solution, that is penta-aquathiocyanatone ion, is destroyed by adding iron ion. So the reason is actually iron ion is more stronger than the this thiocyana ion, so it will displace it and make a colorless solution. So this is the reason. And look here, iron ion is more stronger ligand than the thiocyana ion. When it is added to the complex, it displaces this thiocyana ion. The product form is colorless. So penta-aqua-thiocyanatone ion when reacted with the iron ion, so this will be displaced by the iron ion and this complex will be formed which is colorless. So this is the reason. Thank you so much.